Okay, so today I'm going to spend some time talking about how we are adopting Nextflow in MGnify. So first of all, what the heck is MGnify? So MGnify is the EBI metagenomics resource, which basically means we run a free-to-use service for the metagenomics analysis. So anyone in the scientific community can request an analysis for us. So then we run a set of pipelines that we version, and then we give them back data products through our website, basically. This relatively busy image tries to depict all the different data products that we have and we produce for the users. So let's go bit by bit. First of all, we do cover a lot of, because we take data from the community, we cover a wide range of biomes. We have analyzed so far over 5,000 studies. And we basically take raw sequencing data from amplicon sequencing data, whole genome sequencing data, and meta-transcriptomic data. We run a set of analysis pipelines on the data, and we upload the results into our website, which users can use, but we also provide the results through our web API. Another service that we provide for the community is that we offer them the ability to assemble the whole genome sequencing data. We produce a metagenomics assemblies for them. We also analyze those assemblies, and we also, using the same infrastructure, and then we also provide the results back through our website and APIs. One byproduct of this is that we collect all the sequencing, coding sequencings that we find in those assemblies. We have been collecting those proteins, as we call them, for the last, 10 years. So we have generated a massive amount of data. We have 2.5 billion proteins already, not just the coding sequences, but we also have the provenance, so we know which country that protein comes from and which assembly and whatnot. Which has been actually used by the Meta folks for the ESM fold thingy. And last, another data product that we provide for the users is that the ones that we have those assemblies, we bin those assemblies and we generate metagenome assembled genomes. And we have nearly 500,000 genomes through our website and whatnot. So basically, all of this is done using pipelines, and not just bioinformatics pipelines. It requires a bunch of moving data across our on-prem HPC cluster, crunching data, transforming data, but also running the analysis themselves. Not only we have a lot of pipelines, we also run them quite a lot. So that's sort of like the context for this talk. A bit of history how MGnify has evolved. We are in between sort of like a production service, but we also are an academic institution, so we are in a weird situation, I would say. So as I say, our pipelines are versioned. We have released 5 versions at the moment. We are working in the version 6 of our pipelines. So between version 1 and 4.1, basically everything was done using Python in a sort of like proto workflow management system. And that was more than 6 years ago. And that worked well at the time because the pipelines themselves were quite simple, I would say, only a few tools, and were like really tailored to our infrastructure. At some point, we decided to move away from that because it was not really scaling up. And we decided to port our pipelines into the workflow, the common workflow language. And using Bioconda a lot to manage the software and whatnot. And that worked at the time, but then for version 6, which has been in the works for the past year and a half, we decided to move entirely to Nextflow. I'm basically using containers for everything. And this is just to make it easier for ourselves, because it's really important for us to be able to build simple service, because the turnaround at EBI is quite high. And there are some particular reasons for that. So we needed a simple system that relies on community standards to basically be able to sustain the server in the long term. Again, by using Nextflow, you get exposed to NF Core a lot. And then basically, that was an easy pick for me to take all the good practices that you guys have been building over the years. Because I am a software developer, NF Core and all the good software development practices just fit into my mental model. So just like, okay, this is the stuff that we need to use. So why did we choose Nextflow? That's sort of like the idea of this talk. So first, when we were like with version 5, even though CWL, the common workflow language, worked at the time, it did present some issues. Basically, the developer experience wasn't really great. So as soon as I was like feeding with Nextflow, I was like, okay, this is massively easier for me to understand and work with. We were having issues scaling CWL, not just in the running many jobs, but also in the complex. Our pipelines were becoming quite complex, and because we deal with public data, we have a lot of edge cases that we need to handle. CWL is a bit, it doesn't really handle like edge cases very well. And Nextflow, with being sort of like a language, it was much more suitable for that. Again, we are a relatively small service at EBI, so we need to rely on the community. The CWL community wasn't as big as the Nextflow one. The Nextflow one was basically growing a lot, and it has been growing a lot over the past few years, not just outside of EBI, but also at EBI. EBI basically adopted Nextflow as the recommended workflow management system, so that made it quite easy for me to say, okay, we need to move there. Again, being able to run Nextflow in different HPC infrastructure was quite a neat thing that we wanted to use, because we do work with a lot of collaborators running our pipelines in different HPC clusters. So that was a big plus. We recently went to the transition from IBM LSF to Slum, and that was like just a config file. That doesn't like prove my point very well. Every now and then we get cloud credits, so we like to run pipelines in the cloud if we can, just for fun and profit. So Nextflow fits really well in that setting. Another weak selling point when I was trying to force our team to move to Nextflow is like I was using Secure Platform to show to my boss, look, now you can see where the pipeline is going, all the different steps. But you can also see the efficiency of our pipelines, because I was struggling to demonstrate that we were like not being very efficient. So you can see now, okay, CPU, 1% efficiency. Okay, that's something that we need to improve. And it was having that ability to be very visual really worked really well. And then again, NF Core, it really fits my mental model of how I like to work, having tests, having like a documentation for everything, following a standard that really worked really well. So those are the reasons for that. So that's one side. We moved to Nextflow. That was a really good transition. But then we ran out like a web service, so we wanted to improve how we automate everything. I'm not going to go into too much detail on this one, but this is basically how the system used to work. Basically, a user came to our website. They requested an analysis through our web form. That created a help desk ticket, and there was a lot of back and forth with the user. At some point, someone in our team triggered the analysis of that piece of data that went to the cluster. When the analysis was done, then they went to sort of like the website, I think, and upload the result to the website. Everything was really clunky and manual, so I just wanted to move away from this because it was wasting people's time, and it's not fun to do. So our vision was, okay, let's build a single entry point for our users where they can search data on the European Nucleotide Archive. They can just select which of the studies they want to get analyzed, and they will just like put them on a queue on our system. But I also want the users to know where their analyses are, basically being able to keep track of, okay, my analysis is being on the QC step, my analysis on the whatever it is, that sort of thing. So because I am a software developer, I always try to think, okay, what would be the ideal system for doing that? And you have to understand that our team is basically a few software devs and most bioinformaticians. So the two core technologies that we use are basically Nextflow now and Python. So this pseudo Python language that I wrote, that I'm demonstrating here, is sort of how the system should work, how we can orchestrate all of the things there, how we can pull data from the user using APIs, how we can keep track of things on our DB, like which assemblies we have analyzed, which amplicon datasets we have analyzed, how we can trigger compute jobs directly from this sort of like DSL thingy, and you can see all the components in there. So this was sort of like our goal, how we can build such a system. And basically you can see where each piece of technology we selected for each one of those components. Nextflow is basically the basics of everything. Anything that that is data crunching, anything that is compute intensive is basically done with Nextflow, and we use a Secure platform to keep track of things. That was an easy one. We push all the complexity of handling edge cases or anything that needs to run a piece of software to check the quality of a piece of data, assembling, everything is done with Nextflow, trying to handle all the edge cases within Nextflow if we can. Then we use Django, which is a Python web framework that basically allows us to keep the DB and the API, build the DB and the API, but it also has a really nice DB abstraction layer that you can teach the bioinformaticians without too much trouble. So we can ask them to build these sort of mini workflows, orchestration workflows on their own. And then we use Kubernetes for the web side of things. And then the glue, all of this is Prefect. Prefect is an orchestration workflow management system that basically is built 100% using Python. So basically that sort of brings us, everything is done using either Python or Nextflow. And with Prefect, we sort of handle all the complexity of scheduling stuff in the cluster, running the Nextflow pipelines, keeping track of the DB, keeping all of that. This is the implementation of that, basically. I'm not going into that too much detail. I think the font is maybe too small, but basically there's some kind of flow there that basically assembles and run an analysis. You can see the influence of NF Core there. There's a sample sheet CSV file somewhere. So basically our system takes records from the DB, builds sample sheets, then feed them to Nextflow, and then runs the jobs on the cluster, and then whenever that's ready, try to put that into the website using Django, because you can call Django directly here. To wrap up, a few of the lessons that I've learned over time is there's a steep learning curve, especially in our setting. There's many different components. Nextflow is absolutely great, but it requires you to think in a different way. I always keep being asked why I can't have my an if conditional in my Nextflow pipeline to check for something, because everyone works in a Python way, looking for an imperative way of doing things. Monitoring the storage is absolutely essential. That's more often than not our limiting factor. NF Core is absolutely great, but it's restricting some aspects. So we had to create our own modules repo. We keep track of our own modules in there. We try to contribute back the ones that we can, but it has been great. Prefect works really well, but the Slurm integration adds a bit of complexity because it's not really supported really well. And as a quick summary, our team successfully migrated to Nextflow. We are really happy Nextflow users now. We are trying to engage a bit more with the NF Core community. And I've had a few discussions, and I've learned a lot over the summit, so we're going to try to contribute more. And we are trying to build a new orchestration system for MGnify, built on top of Prefect and Nextflow. And just to highlight, these are sort of the new pipelines we have released over time, so we have become much more productive with Nextflow. And just to say thank you to my team. That's all.
Very interesting talk, thank you. Regarding the workflows and workflows aspect, is there a reason you picked Prefect to orchestrate instead of Nextflow in Nextflow or another tool?
There are two reasons for that. First, we want to keep everything. Basically, it was easier for us because with Prefect, we not only run Nextflow pipelines, we also interface with the DB and other aspects of infrastructure. And doing that with Nextflow did really fit pretty well. So, but that's one thing I was looking at. I think what we are going to do, we're going to rely on some of the metagenomics, so like sample sheet output as an input for the next pipeline, because we need to stitch together a bunch of pipelines. So I think that's the best approach for us.
That's fair. What Nextflow features would you like to help your automation? Is there anything we can do?
One thing that I always struggle with, whenever we run, because we run sample sheets, and because we deal with a lot of public data, sometimes analysis don't go through for, you have 100 samples and one of them is absolutely messed up, actually you can't do anything with it. So we basically push a bunch of conditionals in our Nextflow pipeline to sort of set aside that thing to then report it back so we can then, within prefect, know, okay, this sample has not been analyzed because the QC failed. I don't know how to do that in Nextflow itself. I think we are just doing it in a way that we check, okay, this process is the QC failed, we use the branch operator, then we separate things, and then we sort of like pull things aside. Yeah, I think as a community coming with a set of good practices around that would be nice. I don't know if maybe that already exists. I am not aware of that.
I think there are some folks online who would be very happy to discuss that with you.
Perfect, that would be nice.
So, very good. Thank you.
Okay.
Thank you so much for your talk.
Thank you very much.